Welcome to the Vox Pathfinder 15R channel, and today we have a Vox Pathfinder 15 on the oscilloscope. And the quick setup is that we have the speaker out going to an 8 ohm 100 watt power resistor instead of the speaker. We have a signal generator injecting a 440 hertz signal at 200 millivolts peak to peak to simulate the output of a Stratocaster guitar. We have on the oscilloscope, and we are probing between these. Here are the first two filter capacitors. Here, the big ones right here. These are the C35 and C36, and they are rated at 2200 microfarads at 35 volts. And I'm probing between the ground between these two to the positive rail. And at the moment, I have this oscilloscope set up to 2/10 of a volt per division. We just stabilize it. And at the moment, that's about half a division. So this signal is 1/10 of a volt, or 100 millivolts peak to peak on the positive rail. So let's see, and what I want to talk about is actually how to go about doing diagnostics of whether or not your electrolytic filter capacitors are in good shape. And we are going to concentrate on these first two big ones, C35, C36, and then there's the next set of electrolytics right here. So this is the positive 20 volt and negative 20 volt rails. That's for the power amp chip. And the next set goes between negative 15 and positive 15, and that powers the op amp chips, like in the tremolo circuit and the preamp. And those set of electrolytics, C33, C34, are rated at 47 microfarads at 25 volts. And there's one last pair that's going between positive 9 volts and negative 9 volts. Not certain. That goes to another part of the circuit, perhaps the optocoupler, maybe these transistors, I don't know. And those two, I'm not quite certain what the numbers are. They're buried underneath the electrolytics, and this is fuzzy, but I did see a C and 3 as the beginning of one, so we'll say C31, C32. They're rated at 220 microfarads at 25 volts. So what I want to do, and let's just point those out again. So these two big ones are the first ones in line of your power filtering. And then the second two are these. And then the last in the chain are these two. So what we're going to do as a baseline, we're going to do a temperature setup, a temperature reading, 85, 85, and then we're going to do these two, 88, 88, and then these two, 86 or 88, 88. So let me just write that down. So we're going to say 85 Fahrenheit for the big guys, and then 88 for the smaller ones. So I got this signal, gain and volumes at all the way down. So I'm going to just gradually pull up the gain and the volume. And I'm just looking at the ripple on the rail. So as you inject more signal, you're going to bring down the rail voltage, and the ripples are going to increase in amplitude, and that's with these settings. So then we can just go ahead and do some more temperature readings. Already those are getting a little warmer. Those were 85 degrees Fahrenheit. That's still okay. 89, 90, 86. So this is just one concept of doing diagnostics, because a correctly working electrolytic filtering capacitor has a very low ESR. And once it starts to fail, its ESR increases in time, and that means that the harder it works, one of these capacitors becomes lossier and it starts to overheat more. It can't keep up. So I'm just going to increase the volume. We can look at the ripple as I do that, and it starts to go crazy. And that's just from probing from here to here to ground to the positive rail. And we're approximately 1, 2, maybe 3.5 divisions. So we're looking at about what, 6/10 of a volt now ripple on top of the positive rail. And so we can start looking at the capacitors, you know, for temperature reading. These are staying okay. 91's heating up a little bit. 94. How about these two? 101. Look at that. 103. So we said initially these were 88 degrees Fahrenheit. And ideally they should be balanced. That one's 92 degrees. Now we got a 110. Thought I saw 113. 112. So let's just turn up the volume a little more, where it's starting to clip. Look at that. Here, let me just turn the volume back down, and then I'll just pull it up. Now we're like at, 3/4 volume. Again, check the main caps, 90 degrees about, and they're both even. That's the more important. 92, 94.8, 92. Look at that. So as you can see, there's an asymmetry between these two caps, and that one's heating up. I've had issues of this amplifier cutting out under load, and you could pull the boards, you could desolder, you can, measure stuff. But here's just one technique. Just, that if these capacitors are healthy, they should be in a certain temperature range. They should be even. These are pairs, so there's no reason to believe they should be even with each other, because they're symmetric in their circuits. They should see equal conditions. 117 degrees Fahrenheit. So very suspect, and then I'd probably just replace that pair, instead of just one, because they're in pairs. 99. Now these are starting to drift apart in temperature. Again, they should be, if they're equivalent capacitors, they're equivalent, they're opposite but equal. One's going to the positive rail, one's going to the negative rail. And they should be well matched temperature wise. I mean, these are the most important ones, the first ones. 95. Look at that. So there's your ripple. Let's just track this temperature. (120, 123 degrees peak versus this guy. Still 98 big change. Again, big filter capacitors. And here's the second pair of filtering capacitors. So that's been the Vox Pathfinder 15R channel, and thank you for tuning in.